Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Forge 1.20. And in this tutorial we are going to be continuing our block entity series, and we are going to be covering fluid capabilities for our block entity. So let's go ahead and get started. So as usual, I'm just going to briefly show you what we already have, since I've gone ahead and created all the stuff we're going to need to start with. So obviously we've got the block class, we've got the block entity class, we've got the menu class somewhere as well. So here we go, here's the menu class, and then we also have a screen class that I've set up as well. So these are all just basic stuff. We've covered this all in previous tutorials. The tutorials that you will need for understanding everything we've got so far is the block entities tutorial, or the block tutorial first, of course, the block entity tutorial, the ticking block entity tutorial, the block entity inventory tutorials, the block entity syncing tutorials, the block entity screen, kind of, not really, more so the block entity menu tutorial. That's more important. So I know that in the previous tutorial we talked about packets and how you would need those for this tutorial. It turns out I was actually mistaken, and we're not going to need any packets at all. So this is actually going to be much simpler than I originally intended, which is nice. Once we've got all of those, we can go ahead and start inside of our block entity. So we're going to need a capability, as is usual. So we're going to need a capability as usual. So we'll start by doing a private final, and this is going to be a fluid tank, and that is going to be equal, or we'll first call that something, of course. So we'll call this, for example, fluid tank. Now it is important to note that if you want multiple different fluids, you will need multiple different fluid tanks, and you can also have, for example, I believe multi-fluid tank or something like that. I'm not actually sure what it's called, but I believe there is also a multi-tank, which allows you to have multiple tanks, but it's only of the same fluid. So that's a little bit complicated. We're not going to go into that. We're just going to have one singular tank, but having multiple tanks is basically just copy paste what we are going to be doing. So we'll start with just a fluid tank, and we'll just call this the fluid tank, and that will be equal to a new fluid tank. And in here we need to specify a capacity that this tank will have. So I'm just going to say it should have 10,000, and this is basically the capacity in millibuckets. So obviously millibuckets is basically equivalent to milliliters if you think of it like that. So what, for example, one bucket would be 1,000 millibuckets. So 1 liter, 1,000 milliliters, it's the same kind of thing. So that's how that works. So if we say 10,000, that would basically be 10 buckets of our fluid. And then inside of here, we want to override the onContents_changed method. Oops, not that. onContents_changed. There we go. We want to make sure we call the super method there. I believe we actually don't need to do that, but we'll do that anyways, just in case. And all we're just going to call is, we are going to call example fluid block entity dot this dot send update. So what is this send update method that I've already created here? So you see I'm already using this already for the inventory here, and that is actually one thing we'll just do here as well. We'll just do super.onContents_changed. Once again, we don't need to, but it's kind of recommended to do it anyways. So if we look at send update, you'll see all we're doing is we're setting it to be changed, then we're checking if the level exists. If the level exists, we're just going to send a block update. So that's all we're going to do, and this is basically from our syncing tutorial that we had a while ago. And what that does is that just allows us to use this update packet, where it will go ahead and save the update tag, which just calls our save additional, which in a second we will write our NBT into here. So once we've got our fluid tank, we need to create the lazy optional. So let's go ahead and do a private final lazy optional. This will be of type fluid tank. Now, it is important to note that a fluid tank is kind of the more high level version. The lower level version is both an iFluid handler and an iFluid tank. I believe the iFluid handler is the actual capability. Yeah, you can see this has the auto register capability. So this is the actual capability, and there are other implementations. If we, for example, go to implementations, we can see there's a bunch of different implementations here. For example, you have something like the fluid handler item stack, where the actual item stack holds a fluid, and this is used for buckets, and we'll see this in a second when we go ahead and try and handle that logic ourselves. So this is just a lazy optional of our fluid tank, and then we're just going to call this a fluid optional, and we're just going to set that to lazy optional.of, a supplier of this .fluid tank. There we go. Now there is one other thing that I do want to note, and that is that you can, instead of doing this all like this, right, all kind of in the main part here, you can actually override onload, and you can also initialize them inside of onload instead. If you wished to do that, it doesn't really matter which you do. I just prefer to do it here because then it's loaded basically straight away. None of this is sensitive to a level, so we don't need to have any level for these to exist, and so I don't see a reason to do it inside of onload. But if you had, for example, one of these required a level to actually be created, I don't know why that would be the case. Maybe you accessed some level data or something, then maybe you would want to do it in onload. But since we don't have anything level sensitive, we're not going to do it in onload. I just did want to mention that because I have seen some people doing it in onload, and I just wanted to talk about maybe why you might see them doing that. There is good reason for it if it's necessary for your use case. Now the next thing we'll do is we'll just do the saving and loading, and you guessed, this is going to be exactly the same as with all our other capabilities. We're just going to do p tag, and we're going to put, I'm going to put a fluid tank, and I'm going to do this dot fluid tank dot write to MBT, and we can just write that to a new compound tag. So nice and simple. And we can do the exact same thing with load. So we can do this dot fluid tank, and we can read from MBT, and we can just do p tag dot get compound fluid tank. And it's obviously very important that this name here matches this name here, because obviously if they're not matching, then they won't be able to read or write to each other, or it won't be able to read from what's written, I should say. So that is quite important, of course. Then let's do the get capability. So obviously you can make this sided if you want. I'm not going to do that just because it's a little bit more complicated and more of just a bit of a pain in the ass. So we're not going to worry about that. We're just going to leave it unsided. So that just makes it a bit simpler for us. So we can just say if cap is equal forge capabilities, and we can check if it's the fluid handler capability. If it is, we're just going to return our fluid optional. So we'll return this dot fluid optional dot cast, and that will be our fluid handler done there. And then finally, we need to make sure we invalidate it, of course, because we don't want it to persist around when it shouldn't be. So we're just going to invalidate it inside of invalidate caps. Now finally, let's create these two methods here. So you see I've already got them for the inventory, but we're going to want them for our fluid handler too. So let's go a lazy optional of fluid tank, and in fact we can probably just say get fluid tank, and then we can also say get fluid optional like that, which just makes that a little bit simpler for us. And if we want to make it a little bit easier to read, we can possibly go ahead and put the two optionals together and then put the two actual raw versions together as well. Now the final thing we're actually going to want to do inside of our block entity is the ticking logic. So the simple idea for this specific block is that you can put a bucket or any basically item fluid container inside of the item slot, and what that will do is it will go ahead and transfer the fluid that is inside of that container into our fluid tank. So this is literally just going to be a fluid tank, nothing special, but obviously you could use this for anything you want. For example, maybe you have a machine that generates fluid, maybe you have a machine that takes fluid as an input, all those kind of things. This one's just going to store fluids because that's just easier to demonstrate, really. So we'll start off by grabbing the item stack that is in our slot. So we'll say stack is equal to this.inventory, and we're going to say get stack in slot 0. So that will just get the item in our slot. We're going to check if this is empty. So if the stack is empty, then we're just going to straight up return. Then let's check if we actually have any space inside of our tank, because if we don't, then we're not going to bother proceeding. So we'll say if this.tank, this.fluid tank, and we can say if the fluid amount is greater than or equal to this.tank.capacity, then we can just go ahead and return. And obviously you can inline these two if you wish. Then what we're going to do is we're going to see if this stack actually has a fluid handler. So what we're going to do is we're going to say lazy optional, and this will be of a type iFluidHandler item, and that is going to be a fluid handler. And what this is going to be equal to is the stack, and we're going to call get capability. And then we're going to pass in forge capabilities.fluid handler item. So what we're actually doing here is we're getting a fluid handler item capability instead of a fluid handler capability, and that is because item stacks handle fluids a little bit different, so they have to use an actual different capability in order to be able to do that. So we can just go ahead and get that capability from our stack. And you'll see this is a lazy optional, so we can just say fluid handler, and we can say if present, then that's going to give us the actual fluid handler, right? Or alternatively, you can just say if fluid handler is present if you prefer that kind of way, but we're just going to stick with the functional way because that's kind of the preferred way, I suppose. And then we can get the amount that is in there. So let's say the int amount is going to be equal to our iFluidHandler item, and we're going to drain from that. So the amount that we're going to drain is going to be the amount that we can drain. So we want to try and drain as much as we can actually drain. So we'll say int amount to drain is going to just be equal to this.tank.getCapacity negative this.tank.amount. And so basically that just gets us the amount that is left over from our tank, so how much we can actually fill it with. Now we're just going to try and drain that amount to drain. So we'll do drain amount to drain. And then we're going to pass in a fluid action, so you can either execute or simulate. Now we are going to simulate a drain because we don't actually want to drain it yet. Instead, we actually want to get the amount that could be drained if we did drain it. And we do that so that we can actually check if it's worth trying to drain it. Because if it is worth trying to drain it, then we're also going to need to modify the actual stack inside of the slot. So we can say if amount is going to be greater than 0, and we're also actually going to say and amount is equal to amount to drain. Now if that's the case, we're going to do this.tank, and we are going to call the fill method. So we can fill our tank, and we're going to fill that with iFluidHandler item, and we're going to drain it. So we're going to drain our amount to drain, and then we're going to do the execute action, so fluid action.execute, and then we're also going to do execute for the actual filling as well, so fluid action.execute. Now actually I'm going to extract this out of here. I'm actually going to remove this amount is equal amount to drain, and we'll just do that separately afterwards. So if amount is equal amount to drain, or we'll actually say if amount is greater than, if amount is less than or equal to amount to drain, then we're just going to set it to the actual container item of our handler. So for example, if we had a bucket of water, we would set that to a just bucket. So the way we do that is we just say this.inventory, and we can set stack in slot 0 of course, and we can just set this to the iFluidHandlerItem.getContainer. So that just gets the container item, so whether that be, for example, a bucket, a glass bottle, those kind of things. So effectively what we're saying is we're going to get the actual capability that is associated with the stack. If it's present, then we're going to calculate the amount that we can drain from that stack, or the amount that we can actually take in. Then we're going to attempt to simulate a drain, and we're going to see how much that actually gets us back. If it gets us back anything, then we are going to fill that amount into our tank, and if that amount that we have basically filled, or the amount that we've got back, is less than or equal to the amount that we can drain, right? So if that's actually drained the full tank is what we're saying basically, then we're going to go ahead and set the stack in that slot to the container item for this capability here. So hopefully that should make sense. It is fairly simple, but it's also maybe a little bit complicated if you've never done it before, but hopefully you can wrap your head around that anyways. Now there is one other thing we can do, and more so something that I just want to mention rather than something that we're going to do, and that is instead of using if present, I believe we can actually also say, for example, or else, and what that would do is allow us to actually, for example, throw an exception, maybe if it didn't exist, or you could just have an error message or some kind of thing. We actually don't want that in this specific circumstance, because we want it to be able to drain if it has the handler, but if it doesn't, then we're just going to ignore it. We're not going to do anything. In our case, actually, this is never going to be false, right? So this is always going to be present, and you'll see why in a second. So actually let's show you that now, because we can move on to that now. So we're going to come into the menu, and there is one thing I've done slightly different inside of here, and that is the actual slot here. So you see I've done a fluid container slot, and effectively what this is inside of may place, we determine whether we can actually place it by if that stack has this fluid handler item capability. So if it has the capability, then we allow it to be placed. If it doesn't, then we disallow it to even be placed into that slot. So we just do that, and then I also set the max stack size to 1. That just makes sure that that's never going to happen basically. So we're never going to have, for example, multiple buckets in there, because that would mess up our tick logic. Finally, we can move on to the screen itself and actually render this out. So luckily this should be fairly simple, but we're not going to be doing the best way of doing this, and I'll explain what I mean by that in a moment. So I've just blitted the actual background texture here, and then I've just drawn a kind of background that will be used for our actual fluid drawing. So we're going to start by getting the fluid tank that is inside of our block entity. So let's do fluid tank, and we're just going to call this the tank, and that is going to be equal to this dot menu, and we can call get block entity, and then we can call get fluid tank like that. Then we can actually grab the fluid, so let's go fluid stack, and we can call this the fluid is going to be equal to the tank, and we're just going to call get fluid. So nice and simple, right? And obviously if you had multiple tanks, then you could say get fluid in tank and specify the specific tank, but we're just going to call the get fluid. Then we're going to check if that fluid actually exists. So we just say if the fluid is not empty, then we're going to proceed. We can actually just say if it is empty, then we're going to return, and that just helps us from no longer nesting there. Then what we can do is we can calculate the fluid height that we're going to use. Now I'm going to create a method that will do this for us. So I'm just going to say int fluid height is going to be equal to get fluid height, and that is going to pass in our tank. So let's create this method. Let's go with a private static int get fluid height, and that is just going to take in a iFluid tank, and that will be our tank. And what we're going to return inside of here is we are going to return 48 times, and in brackets we're going to do the tank dot get fluid amount, and we're going to divide that by the tank's capacity. So effectively this will just map our actual tank amount from the amount that's in there to the capacity, and that will just map it between 0 and 48. So that just gets us in a format that we need. And then we can come back into here, and now that we have the fluid height, we're actually going to want to try and grab the texture that is going to be used, and this is where things get a little bit complicated. So unfortunately there's no easy way to just get the texture of a fluid. We can't just do like fluid.getTexture, because you have to remember that fluids are common, so they exist on both the client side and the server side. So we actually have to use something called iClient fluid type extensions, and we can just call this fluid type extensions, and this will allow us to get any of the client stuff that is related to fluids. So we can just do iClient fluid type extensions .of, and we can pass in our actual fluid .get fluid, which gets us the actual fluid of the fluid stack. Then we need to get the texture, so we're going to be using the still texture for this, because that's just the one that makes the most sense in this circumstance. So we'll say resource location still texture is going to be equal to fluid type extensions .get still texture, and you'll see there's a bunch of other stuff that is in here as well. You can get the flowing texture, you can get the overlay texture, you can get the tint color, which we're going to use in a minute. But we want the still texture, and we're just going to pass in our actual fluid stack so that we can get it for the specific stack. Then we're going to check if the fluid texture actually exists, because it's possible that that could not exist. You'll see here that it could return null for empty fluids. Now that shouldn't be possible, because we're checking if the fluid is empty here. But just in case, we're going to do the check anyways. So if still texture is equal null, then we're just going to return. And one thing you could actually do is remove the fluid type and put it further down, since we're not going to need it right this second. Then we're going to need to get an actual texture atlas sprite from this, and this allows us to keep the fluid animations, for example. So we're going to say texture atlas sprite, and we can just call this the sprite, and that is going to be equal to this .minecraft, and we're going to do get texture atlas. We are going to pass in inventory menu .the block atlas, and then we are going to apply that atlas to our resource location that we have here. So that will get us an actual sprite that we can use to draw our texture and keep the animation. Then we want to get the tint color, because if we just draw this texture by default, this will just be gray and it will not be tinted to support our tints. So we're going to say int tint color, and that is going to be equal to our fluid type extensions .get tint color, and we're once again going to pass in our fluid. Now I'm actually going to rename our fluid here because it's a little bit deceiving. Our fluid is actually a fluid stack, So let's rename it accordingly. Let's actually call it a fluid stack. Now the tint color is all nice and well, however we actually need the 4 floats. We need a red, green, blue and alpha instead of just an integer, and you'll see why, because if we do pGUI graphics, so our GUI graphics up here, and if we do .set color, you actually see we need the 4 floats. So let's grab the 4 floats from this integer color. Luckily that should be nice and simple, so we can just do float alpha. Since this tint color is ARGB, you'll see right here alpha, red, green, blue. So float alpha is going to be equal, and we'll say our tint color. Now we are going to shift that 24 places to the right, and then we are going to say and 0xff, and then we divide that by 255, and that basically gets us our alpha in a float from 0 to 1. So if you're a little bit confused about the what's going on here, it's basically just some bitewise operations. This is just how you extract the specific ones. You have to use this math right here. If I can, I'll try and find a video that explains that, but I'm not sure I'll be able to find one since it's kind of specific to Minecraft. But I'll see what I can do to see if I can find you a video about that. If not, just don't really worry about it. It's not something you need to consider that much. Then we're going to grab the red, so we'll do float red, and it's going to be exactly the same really, except this time we're going to shift 16 places, so 0xff, divide that by 255. Then we're going to grab the green channel, so we'll say tint color, and this time we're going to shift 8 places, so we'll go 0xff, divide that by 255, and I've actually done something wrong there by the looks of it. What have I done wrong? Green, I didn't do the equal sign, there we go. Then finally we have the blue channel, which is the final one. So this time we actually don't need to shift it because we're on the final channel basically, so we don't have to shift it anywhere. We can just say and 0xff, and then divide that by 255. And once again, I've somehow forgotten the equals sign. Don't know how I managed that, but there we go. So that gets us our color. Then what we can do is just call that set color method. So we'll say set color. We're going to pass in the alpha, we're going to first pass in the red, then the green, then the blue, and then finally at the end we pass in the alpha. It is very important that you get these the correct way round, otherwise that won't work. So obviously make sure you do that. Then we are going to blit our texture. So we'll say pGUI graphics .blit. Now we're going to actually use a slightly different blit method than we're using up here, since we need to use a texture atlas sprite instead of what we normally use, which is a resource location. So the first one is actually the X position. So we're just going to do this .left pos, and I'm going to say +100. Then we're going to do the Y position. Now we're actually going to make a method that will calculate this Y position. So for now we'll just say get fluid Y, and just note that this is going to take in our fluid height. Just makes it a little bit simpler if we have a method that calculates that for us. Then we have the blit offset. Now we don't have an offset for this, so we're just going to say 0. Then we're going to pass in the width and the height, I believe. Or is this? No, so we're actually going to pass in the U offset and the V offset, I believe. So that is going to be 0, and then on 16. And then finally we're going to pass in the fluid height. And then finally, we're going to pass in the sprite. So you see this is the U offset, this is the V offset, this is the actual fluid height, or the, you see the width there apparently, and then the height. I don't know, I think this is a little bit confused because of this get fluid Y method that's erroring. So let's go ahead and actually create that method. Let's do a private int, and this will be get fluid Y, which is going to take in an int of the fluid height, and from this we can just return basically the top pos. So we'll start always with the top pos, then we can add maybe 15, to kind of pad it out from the top a little bit. And then we're just going to do the actual height, the maximum height of our fluid, which we set to 48, as you can see by this 48 here. And then we're going to minus the fluid height. So that basically means that we can draw from the bottom instead of drawing from the top. Whereas if we didn't hide, or if we didn't subtract from 48, then we would be drawing from the top instead of from the bottom. So this is how we draw from the bottom, of course. And you see get fluid Y, there we go. This is actually still complaining, so it's possible I did actually mess this up. In fact, yes, I did. I put 2 zeros there. We only want 1 0 because this is the blit offset here. Then it's the width here of 16, and then it's the height of the fluid height. So I did mess that up a little bit, but it's fine. Then finally, we want to go ahead and reset our graphics color so that we can draw everything else after it in a normal color. So we'll say just 1.0f for all of these. There we go. You see very funky stuff if you don't do that, because I found that out in testing and it was quite interesting, I must admit. So I guess if you want to test it out by not doing this, then you can see what that does, and you'll see it's very interesting. Finally, what we're going to want to do is we're going to draw a tooltip for when we put the mouse over the fluid. So this will luckily be nice and simple. So let's start by once again getting the fluid tank and then getting the fluid stack. I'm just going to copy that from here. There we go. Then I'm going to grab the fluid height, so int fluid height, and that's why we created our method so that we can use this here as well. So we'll get the fluid height. Then we're going to say if is hovering. Now we're going to start at 100, since that's where we start our fluid. If you see here, we start at left pos plus 100. Then we're going to start at the get fluid Y, and that obviously takes in our fluid height. Now it is important that we need to negative our top pos from this, because is hovering actually automatically negates the top and left pos from this, so we actually don't need to do that. So that basically means we need to negate the top pos, because in here we are adding the top pos to it, so we just need to negate it here. Then we need to actually pass in the width, which is going to be 16, then the height, which will be the fluid height, then the mouse x, so that's just p mouse x, and then p mouse y. So if we are hovering, or we can actually say if we're not hovering, then we just return, of course, because that obviously makes it a little bit simpler for us. It is important, obviously, if you had anything else you wanted to draw in here, that you do that before you do this, or just don't return and have it be a normal kind of if statement instead. But we return so that we don't have all the indentation rubbish. Then we can basically just draw the amount of fluid that is going to be in there as a tooltip, right? So we're actually going to have to make a tooltip for this on the fly, because we want to display the amount of fluid that's in there. So what we can say is component, and that is going to be equal, and we're just going to make a mutable component. So we'll say mutable component.create. We're going to use the fluid display name, so we'll say fluid stack.display name, and we're going to get the contents of that display name. Then we are going to append to this, and we're just going to append basically the amount of fluid that's in there. So we'll say %s out of maybe %s, and that will be in millibuckets, so we'll just say millibuckets to keep it nice and simple. And we can format that string using the tank's amount, and then using the tank's capacity. There we go. Then we can just render this component using the GUI graphics. So P GUI graphics. We can render the tooltip. We can use this.font. We can use the component. Then we can use the mouse X as the X position and the mouse Y as the Y position. So that will just render the component for us there. And that is the final thing that we wanted to do. So what we're going to do is we're going to run the game. We're going to see if it works, and yeah, I will see you inside of the game. Alright, so we are in the game. I've just gone ahead and grabbed some water buckets and some lava buckets and our block. So let's place our block down first of all. You see we have our GUI here, and we have the grey area. This is basically where our fluid is going to be drawn. and you see we have our slot here. Now if you try put any old item in this slot, you see buckets, it works, but for example if we put our block in there, I can't put that in there. I also can't, for example, shift click it in there either, because we overrode made place. We said we can't do that. So let's go ahead and try and put a water bucket in there. And you see actually nothing happened, which is very interesting. However, you will see that there is water in there. That probably means I messed something up, because that actually should display. Let's go into the code here and let's just have a look at what I might have done wrong here. The only thing I can think is possibly the get fluid Y is not correct, or more likely our get fluid height is not correct. So actually here's where we can do some debugging. So what we're going to do is I'm just going to set a breakpoint at our set color here. So we know we're reaching the set color, and we can see some values here. So we can see the alpha is 1, we can see the red is 0.2, the green is 0.4, the blue is 0.8. So that's probably about water. That would make sense. Our fluid texture here, you can see, is Minecraft block water still. So that seems to be correct and all seems fine there. Now, if we go to the fluid height, so let's go into here. Let's step into this method. So let's look at the tank here, and hopefully we can actually see the capacity there is 10,000, and the fluid amount is going to be 2,000. So I think what's actually going on here is that we are doing integer division. So it's basically not working because it's integer division. So we're going to try cast this first integer to a float, and possibly that will fix it. We do obviously then need to cast this whole thing to an integer. It's possible that is going to be the issue. So let's go ahead and actually hot swap that, and I'm just going to resume the program and remove the breakpoint as well. And yes, that actually was the issue. So we just had a floating point issue there. And if we grab some more water buckets as well, and we should also be able to use water bottles as well. So we'll try that too, but I haven't actually tested that, but there's no reason why that shouldn't work in my opinion. You see that just updates instantly, so that's nice and easy. And you see it just continues drawing. So if we try and put a water bottle in here, we actually can't put a water bottle in here. So that's basically says to me that possibly water bottles don't have that same capability. I thought they did, but I guess not, because there's no reason why they shouldn't go in there otherwise. Now, if we try and put lava in there, that actually did work. That's that's definitely not meant to work. So we can actually go ahead and fix that. And it should be fairly simple, really. So basically where we try and drain, before we do this, we're just going to check that the fluids are the same. So we can just say if iFluidHandlerItem dot is fluid valid, or what we can actually do is the other way around. So we can say this dot tank is fluid valid, and we're going to pass in the iFluidHandlerItem and hopefully get the fluid. So get fluid in tank, we have to say tank 0, of course. And now if it's not valid, we can just return, because we know in that case that we don't want to try and drain, because that would be a bit ridiculous. So we can actually hot swap that. Hopefully that still works. And if we try and put lava in there now, that should not work anymore. So that actually still worked. Interesting. Okay, that's very, very interesting. So fluid tank is valid. Is fluid valid? Let's try saying is fluid valid for actually slot 0, so the tank 0. It's also possibly that my hot swapping is not working here, so that's completely possible. We might have to try and restart the game. And it's also possibly we scuffed it up by making that work earlier. So let's just put water in here again. We'll put 2 buckets of water in there. Then we'll try and put lava in there. That still works. That's very interesting. Maybe instead of saying if it's valid, what we can actually say is get fluid, and we can check if it is basically equal. So if the is fluid equal to get fluid in tank 0, so if it's not equal, then we're just going to return. Let's see if that possibly fixes our issue here. So we'll grab lava again, we'll put it in, and yes, that now fixes our issue. So that's just some jank code of mine there, apparently. But yeah, you will want to obviously do that because that's quite important. And yeah, I actually didn't test that previously, so that is a good thing to note, that you do want to do this as well. Just make sure that you can put the fluid in before you try and actually drain it. So that should be basically it. Hopefully this tutorial will still work for custom fluids as well, so when we do those hopefully very soon actually, we should be able to see this working for that too, and obviously we'll test it then. You can see we've got, for example, the tint color there, so that's all good. If we grab water, now there is one other thing I wanted to mention, and I'll show you exactly what I'm talking about. So if we grab a couple of buckets, let's just put them in here, we'll go all the way up. You should be able to see that this is starting to stretch. And that is because our code, unfortunately, for actually rendering the fluid texture, will just straight up stretch the texture. We're not like tiling it or anything. So that is probably something you should do. If you were doing this like for an actual mod or something, you should probably tile your texture instead of just straight up drawing the texture once to fit that whole area. You should actually tile it. Now, I don't have any code to show you on how to do that. However, I will leave a link in the description of this video to the mechanism code and also possibly JEI, since both of those render fluids and they both tile them. You can also look at really any mod that handles fluids. So I believe, for example, Refined Storage does, Applied Energistics, they handle fluids, Immersive Engineering, basically think any tech mod which would have a fluid in a GUI, they will all tile their fluids. So you should look at those, and I'll leave some links in the description. Just don't copy the code. Obviously, if you're going to copy it, make sure you have the correct license permissions to do so. It's not that complicated to tile fluids. I did do it on stream, maybe 10 or so streams ago. I think I did it on stream. I might link that in the description too if you're curious on how I did it. My code was a little bit janky though because I didn't really do it the right way, but basically you just draw the leftover, so you just loop over until you've filled up the whole area basically. So it's not really complicated, it's just a little bit messy, and I think it was a bit beyond the scope of this tutorial, so we won't be covering that. But in a future tutorial, we will be talking about how to actually render a fluid in the world inside of our block entity. So that should be exciting. But first, we obviously need to cover actually block entity renderers so that we can just render, for example, items we'll start with, and then we'll go on to fluids, since fluids are going to be quite complicated for that. We're going to have to draw some quads and stuff, so that will be quite exciting and should be soon. Possibly, it won't be the next tutorial. The next tutorial will be block entity renderers, and then possibly GeckoLib for block entity renderers might be the one after that, and then possibly fluid rendering. We'll see. I'm not exactly sure on the order as of right now, but it's going to be something like that. And then we'll move on to, you know, the rest of the stuff. So we'll basically quit the block entity series at that point. And then my plan is to do a series on mix-ins, which will be exciting. And possibly I'm considering looking into doing tutorials on JS core mods, but I'm not sure whether I'm going to do that because those are a little bit, well, they are extremely complex. The most complex thing you can do in modding. So I'm not sure whether I'm going to cover those. I might. They're also quite dangerous. Well, not dangerous, but it's complicated anyways. So I'm not sure whether I'll do those. I haven't decided yet, but I just thought I'd let you guys know. That's kind of my plans for the next coming up tutorials. So obviously, if you found this one useful, please do be sure to give it a like and subscribe. If you really found it useful, then obviously you can join my Patreon, which helps to support me. Link is in the description. And if you have any problems or you're getting stuck with anything, it doesn't have to be related to this tutorial, any tutorial really. You can join my Discord server, which is also linked in the description, or you can just come and hang out there and chat as well. That's fine too, and I will see you in the next tutorial. Goodbye.